In this video, we will demonstrate the part builder creating schematic symbols for a Xilinx 484-pin Artix7 FPGA. The flow for most Xilinx devices is very similar. We start by using Vivado, and we're going to use the write CSV command in the Tickle console to create the pin data file. So we created it in my downloads file, and now we're going to go look at that. And we take a look in there. We're going to open it up and expand it. And we can see in here that we can see all the pin names, the pin numbers, and across the top there's a header with all the extra information. And Part Builder makes use of a lot of this information. Next, we start Part Builder. And we're going to create a new part folder using the menu item next to the part config file there. It says Create New Part Folder. We get a pop-up here that lets us choose a working directory and the new part name. So whatever we type in the new part name, it's going to create a folder under the working directory when we hit Create New. And there it's also going to save a simgencontrol.txt file. And when we say Done, and now we can see the part name got set to XC7A5TFFG484, which is what we entered there. So now we're going to set the pin report type to Xilinx Physical. And then we're going to browse to find the pin report file we created using Vivado. So we're going to go over to the downloads file, and we're going to find that CSV file, and then we get a pop-up here that says the selected pin report file is not in the local part folder. Would you like to make a local copy? And we'll say yes. So next we're going to read the pin report using the read pin report operation. And it's going to say, okay, I found 484 pins in the selected pinout report. Would you like to set the num pin fields to correspond? And we'll say yes. And then we'll get this new warning that we can ignore. Now we're going to run the SmartFrack operation, which creates the initial SDL file for us. We double-click the SmartFrack, and now we're going to go back and take a look at what SmartFrack found for us. So it goes up to the top, and since SmartFrack is smart about FPGAs, it found dedicated I/O banks, it found 6 generic I/O banks, and it found 1 transceiver bank, bank 216. So it's going to use that to sort the pinout information for us very intelligently and do most of the work that it takes to create a symbol for an FPGA. So next step, we open the SDL editor to see what SmartFrack created. And the first thing we're going to do is we're going to take the dedicated I/O banks and we're going to move it to an include file. So we're going to select from row 8 all the way down to row 27, and then we're going to right click and use the move selection to include file. And what this is, then we select a file name and we're going to save it as Artix7 config file, or Xilinx Artix7 config.sdl or pins.sdl. And once we save that, we're going to see that it disappears from this file. And now what we're going to do is save the SDL file and follow the prompts to rename it so our work won't be overwritten by SmartFrack the next time it runs. So we're going to save, hit the save button, and we're going to get prompted that we might be overwritten, so we need a new file name. And we're going to name this one top symbol.sdl. So we call it top because it has an include file in it. And now we're going to look around what's left from what SmartFrack created for us, and we can see all the FPGA banks and this new include file. So we got banks 13, 14, and 15, 16, 34, 35. We got 216, and we got the power pins. So SmartFrack created all of that for us, and we didn't have to do any work to organize this. Our next job is to go back and edit the include file we created for the Artix7 family config pins. Unfortunately, it's a little off the screen, but we select the include file and we right-click and say Edit Include File. And the SDL editor opens with the new file for us to edit. So here we're going to reorder the pins and space them out with balance sim side and spacer commands. So the first thing we're doing is moving the VCC BAT and VCC O up to the top by cutting and pasting. Then we're going to insert a balanced symbol size to separate that from the next set of pins. And next we're going to do that with the VCC ADC parts. We'll insert a balanced symbol size to select them. Now we'll find the other analog pins like the VP and the VREF-P, and we'll take them, we'll cut them, and we'll move them up to the analog section. So, and also with the DXP pins. Then we'll set a balanced symbol size. We'll separate the JTAG pins and the config pins, and then we'll play around. We'll move the config BS under the mode pins and put a spacer in there. And now we save our edits to this file, and we close the top level SDL file. So now that we finished editing the SDL, we're going to go build the symbols using the operation on the main GUI. And once we hit run, it doesn't take long at all to create the files. And we can see we created the symbols for the Allegro HDL tool all the way down to the Zukin tool in that amount of time. So now we're going to move around, and we're going to go to the view symbol and hit the HTML symbol viewer and look at our banks. Here's the config pins that we created for the part. And this is a reusable part. This can be used with any Artix7 part now because we made it an include file. Then we move on, and we can see the generic banks, VCC 13, 14, 15, 16, 34, 35. And then here we'll pause to take a look at the MGT banks that we did. And we can see the receivers on the left, the transmitters on the right, and the ref clocks and the reference pin on the bottom. And then we move to the power pin. The power pins may not be exactly what we want. We might want to reorganize the MGTA, VCC, and VTT together, but that's very simple to do in the SDL editor with one little edit. So let's take a look at reorganizing the symbol. What I'd really want to have happen is VCC aux to come to the top, VCC BRAM next, and then this MGTA VTT one come down here. So how do we do that? We're going to open the SDL editor again, slide it into our window so we can see, and then move down to the power pins. So here we are. Let's look. So we have VCC in on the top, we have MGTA VTT on the right. Well, let's move that. So we'll delete this spacer. We'll cut the MGTA VTT, move it down here on the right, and then we'll move VCC BRAM up. So on the left we'll have 14 VCC in pins, on the right we'll have VCC aux, on the right we'll have VCC BRAM, and let's put a spacer between that. So we want, that's on the right side, so we want a right spacer, and we want to put two spacers in there, so we can say 1 to 0. And we'll save this. We'll rerun build symbols from there. And then let's go look at the symbol viewer again one more time. And we'll just go straight to the power pins. So now we have VCC int, like we said, VCC aux, VCC BRAM, MGTA VCC, and MGTA VTT. And let's quickly take a look at the symbol description language next to that we have. So on the left we have VCC int, 14 pins. On the right we have VCC aux. We have a spacer with 2 pins, 2 spaces, and then we put VCC BRAM. We did a balanced symbol size +2, so that pushes both sides down from the lowest point, which was here. And then we put MGTA VCC and MGTA VTT. So let's close that, and we're done. Thanks for watching. Please visit us at www.cadenhance.com/downloads to download a copy of the tools and take them for a free 30-day test drive.